Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Kropki Dots in Irregular Regions by MD88 Keys. Um, let's get to the rules. We have normal and irregular Sudoku rules apply, which means place the digits 1 through 9 in every row, column, 3 by 3 box, and irregular region marked by cages. So that means normal Sudoku rules apply, which means we in every cell in the grid place a single digit from 1 through 9 such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. And in addition, every cage also contains the digits 1 through 9 exactly once each. So there's that. We have black dots connect cells in a 2-to-1 ratio, and white dot connects consecutive cells, and not all dots are necessarily given. So for example, if this were a 2, this would have to be 1 or 4 to maintain the 1-to-2 ratio between them. And if this were, say, 6, this would have to be 5 or 7 to be consecutive with it. And note, for clarity, cells that are not in any cage are shaded gray. And there should be 9 of them, right? Because we should have 8 irregular regions. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we do have 9. Please fill them with the correct digits. So there are digits in these gray cells also. It's just that they do not. Actually, that actually also has to form a set of digits from 1 through 9. Right? Because since each of the cages contains a set of the digits 1 through 9, and we have 8 cages, that means the leftovers should be the digits 1 through 9 also. Right? Because we have accounted for 8 of each of the digits, so we need a ninth one for each of the remaining digits, which is 1 each. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, we have a set of 3 cells, one of which is in a 1-to-2 ratio with the other 2. And they are both unique. So this must be 2 or 4. Which can be next to 1, 2, 4, 8, 1, 2, 4, 8. If this were 1, that doesn't work because that would be force this to be 2 and this to be 2. But again, we have to have unique digits in each of the cages. So this cannot be 1. This could be 1, 2, 4, and this is 3 or 5. Or 1, 2, 4. So 1, 2, 4 with 3 or 5. 2, 4, 8 with 7 or 9. 4, it can't be 4, 2, 1. So this cannot be 4. And it could be 8, 4, 2 with this 1 or 3. Okay. We have, in this cage, 3 sets of digits, which are in a 1-to-2 ratio. So that must be 1, 2, 3, 4, 6, and 8. So the remaining digits in that cage are 5, 7, 9. Okay. This cell is seen by these 4. Is that helpful? I don't know. We have a 1-to-2 ratio, and then we have consecutive digits, consecutive digits, consecutive digits. These 3 digits must be exactly equal to those 3, because these 6 are the same. These cannot contain 2 or 4 remaining in row 4. So for the consecutive digits, it cannot contain 2 or 4. It must have an even digit to be consecutive. So it would be 6 or 8 with 5, 7, or 9. Okay. Hmm. These 2 digits must match these 2. So this is 1, 3, 5, 6, 7, 8, 9. So this is consecutive also, and it cannot contain 2 or 4. So this must have 6 or 8 with 5, 7, or 9. Because in this cage, we are guaranteed that one of these digits is 2 in these 3 digits, and one of these digits is 4. That's the reason why we know that. This digit is consecutive with 2 other digits, so it's 2 through 8. Do we have anything else? And the rest of this cage cannot have 2 or 4. So we have 1, 3, 5, 6, 7, 8, 9. Okay. Interesting. Where are 2 and 4? So this is odd. We know that for certain. So this is going to be odd. These are even. This is 1 odd, 1 even. 1 odd, 1 even. That means 3 odds and 2 evens accounted for. Hmm. This is 1 odd and even, 1 odd and even, 1 odd and even. So that's 3 evens accounted for in this cage. Therefore, you cannot have 2 evens here, because that's 3 out of the 4 evens are already accounted for. So this must be an odd and an even pair. So this is either 1, 2, or it's 3, 6. Okay. We are guaranteed a 4 here, so this cannot be 4. Where is the 4 in column 6? Or 4. It has to be one of these 3 digits. Okay. Hmm. So this has to be an odd digit. So it's 1, 3, 5, 7, 9 there. We have 1 odd, 1 even there. These are all odd digits. This is 1 odd, 1 even. We don't know about these. This digit cannot see any of these, cannot be any of these, cannot be here, so it must be this digit here. So this is odd, which forces this to be even. And it's 4, 6, or 8. Right? Because where is... It has to be somewhere in this cage. It can't be either of these two because these can't be 5, 7, 9. It can't be any of these because they're in the same box. So it can't be here because they're in the same row, so it has to be there. Okay. That means this cannot be a 4-8 pair. If this is 4-8 as a pair, where are 4 and 8 going to be in this cage? Can't be here because again, one of these must be odd, one must be even. And this is going to be consecutive. So this cannot be 8 here. There has to be an 8 in one of these 5 cells there, then. We have 4 odds in box 7. So this could be 2 evens. Hmm. So 4 is guaranteed to be here, which eliminates 4 in the rest of the box, so this cannot be 8, because that would force this to be 4. Hmm. 4 has to be one of these. 2 also. So 2 is one of these 3 here, which means this can't be 2 in box 4. So 2 could be any of... Oh, 4 could technically also be here. These 2 digits are the same as these. So they also have to be 2 out of the 3 digits here. This is 1 odd, 1 even. This is 1 odd, 1 even. So we have 4 odds and 3 evens in box 8, so this must be an odd and an even. Okay. Hmm. Hmm. Um... Uh, so this has to be in a 1 to 2 ratio in one of these 3 cells. This is again 1, 2, 3, 4, 6, 8. Oops. Remaining digits of row 4 are 1, 3, 5, 6, 7, 8, 9. Okay. So again, this is A. That's the same as that, so A has to be one of these 3. We'll make these Z. Z must be one of those 2, so it must match one of those 3. These 3 digits, we'll call them Y, must match those 3. Oh, these 2 digits, where are they in this cage? They have to be these 2 digits. So these are the same pair as these. So it cannot have a 4 here. Interesting. This digit must match this digit here. We have 1 odd and even here. That's the same as this odd and even here. Because there's no other place for it in this cage, except for these 2 cells. Um, right, because these are not going to be consecutive, essentially. Um, because this matches that cell. Um, hmm. So these must match this. We're going to make this X must be exactly those two. Um, hmm. That means this cell, where is it in box 7? Can't be any of these. Can't match this, can't match that, so it has to be that. So this is 4, 6, or 8. I guess it'll be, we'll make it C or B. We'll match that B. So then B has to be one of those 3. Um, hmm. Ugh. Um, Interesting. So these 2 digits cannot appear anywhere of these. So one of these 2 must be that digit there. Huh. So let's mark this as green. These are the same ones. We'll mark this as yellow, and we'll mark this as orange. Okay, so one of these is green. So this cannot be 4 or 8, because it sees one of these is a 4-8 pair, and it sees both of those cells. Okay. Um. Hmm. Um. Hmm. Hmm. Um. Hmm. Oh, where is B in this cage here? Can't be here. Can't be here. Can't be here. So it must be here. So this is definitely B. This is Z here. This is definitely B and is even. So this must be odd here. And it has to be 3, 5, 7, 9. Because this is 4, 6, 8. Hmm. B then cannot be here for this region or here. So B has to be one of these 4. Hmm. Hmm. Where is this cell here? It can't be in any of the cage, can't be in the same row, so it has to be this cell here. So this C matches C here. And then it has to be one of these two cells here. Interesting. So C matches that cell there. Because it can't be any part of the same region. So this is rolled out. Can't be in the same row, so it has to be C there. Which means C cannot be any of these. C could be one of these four. Has to be one of those four. C cannot be any of these. C can't be here. C is one of these four. And these two digits specifically have to match these two. So we'll mark those as, I don't know. W must match those two specifically. Interesting. Hmm. Hmm. So we have one odd, one even here. One odd, one even here. One odd, one even here. That doesn't tell us anything. So these are consecutive. That's interesting. Huh. Okay. We have one odd and even here. These are three are odd. This is one odd and even here because it matches those. So this must be even. So this is even, which forces this to be even. Therefore, this must be odd here. Because again, this is odd even pair. So we have odd, 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 odd. That's four odds. One of these is going to be odd because they match these two cells. So this must be even here. So C has to be one of these three digits here. We're not sure which. Because it can't be here because of the C that's there. Can't be an odd digit. So it's one of those three. C is even, so therefore the other one's odd. The odd one could be here. Or it could be that one. We don't know which. I'm going to pause. I need to go to the bathroom right now. I'll be right back. And I'm back. Okay, let's continue. What other information do we have? We know these four have to be 4 out of those 7. That doesn't tell us too much. Um, hmm. Hmm, 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 hmm. Mm, 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 mm. Oh, so W has to be. It cannot be here. It has to be these W, and it has to match these cells. Then, so those are guaranteed to be W. Where is this digit? It cannot be the same as these. It can't be the even cells. It can't be the X's. And it can't be W's, so it has to be this cell here. So we'll mark that as D. It must be D here, which means D has to be there. Hmm. That means this cannot be D, so the other one matching here must be here. So we have E, and this is a CE pair here. The W is matched there. So this is C and E. E has to be one of these two. Okay, what's the remaining cell then here? I guess we need both of these X's. So one of them has to be here. So this one has to be here, and this one has to be one of those 3. Huh. Okay. Um, so C also has to be 4, 6, or 8 here. Interesting. But you could still have 3 and 6 here. Hmm. The remaining 3 digits here have to match these 3. Hmm. Huh. Uh, this cell must be one of these 3. Is that helpful? I don't really know. Uh, 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 Oh. Um. Hmm. Huh. Hmm. Oh, this can't be 3 because it. Oh wait, it could be. We don't know which of these matches E. Huh. The orange cell here cannot be any of these. Can't match that. So it could be here. It could be any of these 5. That seems fine. Uh, so this has to be either orange or yellow as a pair because it can't be green as a 1-2 pair. Okay. Or it could be some combination. Right. Well, if it were some combination. Okay, so this. Yeah, that's why it could be yellow and orange, right? It's not just guaranteed that this is yellow. Um, Let's see. Hmm. Huh. Where is A in box 4? Can't be next to any of the Kropki dots because it's 5, 7, 9. Can't be here. So A has to be one of these two. A cannot be here, here, cannot be here because it's one of these two cells. Can't be here because we already have it in the region. Can't be here because of A in the column, so A actually has to be one of these two. That's interesting. Oh, well, where's A in row? Well, where's A in box 6? Can't be here because of A in the row. Can't be here because of A in the cage, so A has to be one of these two, which means this cannot be A. This is A here and is odd. So it's 5, 7, 9, which is next to an even. Um, B cannot be here. So this A is next to two unique digits. So it cannot be 9 that are even. So this is not 9. This is 4, 6, or 8 also. Cannot be C. Interesting. So this has to be another 4, 6, 8 even. So it's not C, it's not B. It's probably one of the W's or X's. We're not sure which. So we're going to mark it as, I don't know, F. Because we already have a C in the region. We don't have a B, but it can't be B because of the B already in the column. Hmm. This cell, so we have A, E, this is F, I guess we'll make this G. A, E, and G are unique. E is one of these. A is here. G could be the same as D. Or it could be W. We don't know. Either way, G cannot be any of these cells because they're next to black Kropki dots, can't be here, so G has to be one of these three. Since this is G, G has to be one of these three. Um, um, hmm. Okay. Hmm. Um, hmm. Yeah, this can't be 6, but it doesn't matter. Uh, this is either 5, which forces B and F to be 4 and 6, or it's 7, which forces B and F to be 6 and 8. So C can never be 6. C has to be 4 or 8. Interesting. Um, wait, why can't F be the same as C? Oh, because we have a C here. Right. Hmm. Hmm. Mm. Hmm. Oh. Where is A? Right. Where is A in column 4? Can't be here because of A's in the boxes. Can't be here because it's 5 or 7, so this must be A here. Which means this is guaranteed to be 4. So this is 4 with 2 or 8. This has to be A and is odd. It's 5 or 7. So this is A. We have A here. A here. Okay. A cannot be missing in any other gray region, so neither can B. B is 4 or 8. Oh, whoops. I had C as 4 and 8. Oops. Okay, so this is 4, 6, or 8 still. Hmm. This is 2 evens guaranteed. This is then 1 odd and 1 even. 1 odd, 1 even. So that's guaranteed all the evens in box 2, so this must be odd. So this is odd, not 6 or 8. So we have odd here, odd here. Um, hmm. Oh, that's interesting. Hmm. So A cannot be here. Because it would be then another odd digit. It can only be in one of the gray areas once. Okay. Hmm. We have odd, odd, odd. Another odd here with the even. Um. Hmm. Okay. Oh, we have a 579 triplet, which eliminates 579 in column 4. So this can't be 579. It's 6 or 8, which is even. So this must be odd. Cannot be 6 or 8. It's 5, 7, or 9. So it cannot be A. This is either E or G. We're not sure which. This is 6, 8. We have 2 odds here. This is 5, 7, 9. These are all even. So these are 3 evens. This is one of these is even, so this cannot be even. It has to be odd, which means this is 1 or 3, which means this has to be 2 or 6 here. So this is 1, 2, 3, 6 as a quadruplet, which forces this to be a 4, 8 pair here. So this is 4 and 8 as a pair, which means this must be C. So this cannot be C here, cannot be C here. So this has to be both greens. Because this can no longer be, it has to, if this is 1, 2, this must be 1, 2. If it's 3, 6, this must be 3, 6. So these match the greens then. Okay, so then this is not 4 or 8. This can't be 8. No 8 here. So the X's then... These are both yellow. Orange. These are both yellow. So this is 4, 8. Oh, it doesn't have to be. It could be orange with the yellow. Right. So that still could be 4, 2. We don't know which. Okay. This is odd. D could be the same as G. Right, these are the same. D could be the same as G. It's one of these 4, but we don't know which. This is an even digit. So we have 4 even digits in box 4, so the rest of the digits must be odd. So no 6. This is also not 2, 4, 6, or 8. So these are all odd. Interesting. So 1 out of these 3 is even. The rest are odd. So that's 1 even, 2 odds, 1 even, 1 odd. So these are even. I guess we move the yellow. This is not helpful, so we just know those are even. This is definitely C. So this cannot be C, this is E. Which is odd. And this is C as an even. Okay. We know C has to be one of these 3. C cannot be here, so C is one of these 4. That's not too helpful. This can't be C or F. This can't be C, F, or B. So it cannot be 4, 6, or 8. So then this has to be, well, not 6. So therefore this can't be 3. But we don't know if this is odd or even. That's the problem, right? So one of these is guaranteed to be a 6 here. Which means this cannot be 6 here. B cannot be either of these. B is one of these 3. No, it can't be here. B is one of these 2 then. Okay. B cannot be here. B cannot be here. So B has to be either here or one of these 2. We don't know which. Ah, well. Yeah, no, it doesn't help. We know B is in between A and this digit here. We don't know if that's E or not. Could be E, could be something else. So E is here, which means E cannot be here. So E can be one of these three. Hmm. B has to be one of these three here. And we know these two match these. So D also has to match with one of those three. Um. Hmm. So we have G. Let's make these actually X. So these are X and H. This is an H. But it could be AG or, no Y. A or G, possibly too. Or E. Hmm. Um, so that means this is guaranteed to be X. Because one of these is X. It has to be one of those two. Cannot be here, so it has to be here. So this is guaranteed to be X. So this is a green. And then this one matches here and is one of those two. Okay. Uh... Hmm. Huh. Okay. Okay. That's interesting. So this is 1, 2, 3, or 6. That means of this pair, the even pair is definitely in one of these two. And this is the even pair of the other set. So we guarantee we cannot have 2 and 8, 2 and 6 in the rest of column 3. So this cannot be 2 or 6. Well, we already knew that. It's 4 or 8. This is E. It's 5, 7, or 9. That's fine. This can't be 2. This is odd, so it's 1, 3, 5, 7, 9. B is one of these three. It's one of those two. C is here, C is here, C is one of those three. Hmm. Hmm. Where is A in this cage here? Cannot be here because one of these two is A. Can't be any of these because A sees them all here. So therefore this must be A here, which means this cannot be A. So this is odd and is A, and it's 5 or 7. It cannot be G. So this is not G. G is one of these two. Because this is G here, which means none of these can be G. Because it's 5, 7, or 9. One of these is G. G has to be one of those two. We need a G in this region, so G is either here or here. G is not the same as A. It could be with W, it could be with D. We don't know which. So X in both sets have to be here. C and E are consecutive. A and B are consecutive. W is consecutive. So can this actually be 3, 6? If this is 3, 6, I guess so, then this would be 1, 2. If this is 1, 2, so D can never be 1. If we try to have a, if we try to have a 1 here, this would force this to be 3, 6 as a pair. Where would 2 be? It would have to be with a W, and then 2 would have to be consecutive with 1 or 3, but 1's accounted for by the D, and 3 is accounted for by this 1, 2 pair. So D can never be 1. It's 3, 5, 7, 9. Well, we already knew that anyways. Oh, no, we didn't. We actually didn't know that. Never mind. Interesting. So we have C here. We have F here. We need B somewhere. B cannot be there. So this already has a C and an F accounted for. So B can't be here. So it's no 4, 6, or 8. So this is 1, 3, 5, 7, 9, or 2. These cannot be 4, 6. Well, these could be B. So, Okay. Is this helpful? I don't know. Where's B in box 5? It has to be here, here, or here. Oh, cannot be here. Because one of these two is B. So B cannot be here, B cannot be here. B has to be one of these two. Okay. Which means where's B in row 6? Can't be here because of B's in the boxes. Can't be here, so B has to be here. Okay, so this is 4, 6, and 8, which is consecutive with 3, 5, 7, 9. Um, um, hmm. Where is 2 in row 6 then? 2 in row 6 has to be either here or here. Hmm. B cannot be here. So B has to be one of these 6. B can't be here. Oh, we already have B. No. This is another one. This is a different one. Hmm. If this is B, then obviously B has to be there. If this is B, then obviously B has to be there. Hmm. So B in box 2 has to be one of these 4. B in box 3 is one of these 6. That's not helpful. The rest of this cage cannot have 4, 6, or 8. I guess that's useful. So 1, 2, 3, 5, 7, 9. 1, 2, 3, 5, 7, 9. 5, 7, 9. Okay, so the problem, this could be very a wide possibility of, yeah, it's a wide, it could be many things. um um huh. Is that helpful? I don't know. Hmm. Um. Oh, where is A in box 1? A is here. So A cannot be here. A cannot be here. A cannot be the gray cell because we already have an A in the gray cell. So it can't, but it could be here. Dang it. Okay. Yeah, never mind. This is not 9 though. Because A is between 2 unique digits. Or is consecutive with 2 unique digits, I should say. Yeah, so A could be one of these 3. A is not here. So A can't be here, here. A is one of these four. This can't be A. These four cells must match these four cells. Hmm. 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 Um. Hmm. Oh. Okay. Well, no. Okay, never mind. I was like, F, where's F? But the problem is, F is here, cannot be here, but it could very well be there. Or it could be part of X. We don't know. Mm, 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 hmm. Ugh. Yeah, this is definitely hard. Very cool though. I do like the interactions. It's difficult though. Hmm. Hmm. If this is 1, 2, this has to be 3 and 6. This would then be 4, 8. So then this would be 6. Um, hmm. That doesn't tell us very much though. Hmm. Hmm. E could be here. Oh wait, can it? Say E was here. If this was E, We have E here, E here. That eliminates E from being here because of E's in the column. This can't be E because of E in the region, which means this can't be E either because it's one of the X's. So this can never be E. This has to be E. B could be consecutive with E. We're not... E's consecutive with C. We don't know if that's C. C cannot be here and here or here. So C is one of these three. C then has to be one of these four. It cannot be here, so C is one of these three. So C is one of these three here. It's also one of these three here. So this could be E and C are both consecutive. So this has to be E. This is E. E has to be one of these three. Interesting. So this could be a CE pair. We're not sure. A is not consecutive with C. So A cannot be here or here or here. If we try to have A be here, I don't think that works. If this is A, it would be consecutive with C or E. It could not be consecutive with E because those are both odds, and A can never be consecutive with C because it's consecutive only with B and F. Because C has to be there. So this cannot be A. These can't be A. These can't be A. This can't be A. So A has to be one of these two. Since A is one of these two, that means A cannot be here. A is one of those two there. Okay. So, can this ever be... This can't be 2 and 3, obviously, because that would eliminate all possibilities for this pair here being in a 1 and 2 ratio. If it's 1, 2 here, I think that... Oh, that doesn't work. Because we're guaranteed C and E have to be here. In one of these three cells. And if it's 1, 2, that would not work. So C and E cannot... This cannot be a 1, 2 pair here. So this has to be 3 through 9. Oh boy. There's so many possibilities. It could just be a CE as a pair there. Hmm. 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 We are guaranteed. Okay, there we go. Where is 6 in row 6? Can't be here because, again, A is consecutive with B and F, and it's 5 or 7 then, which means it's 4, 5, 6 or 6, 7, 8. Either way, B and F have to contain a 6, so therefore this can't be 6, these can't be 6. This can't be 6 because of the odd or evenness. One of these is guaranteed to be 6 here, which means 6 cannot appear in the rest of box 6. So this can't be 6, this can't be 6. Where is the 6 then in row 4? The only place possible is here. So this is 6, which means this is 5 or 9 as E. Therefore, G has to be a 9. So this is 6, which means this is not 3 and 6. This is 1, 2 as a pair. That forces this to be a 4, 8 pair here. This is 6. This can't be 1. This is then 3. And that must be 6. This can't be 6. It's 1 and 2. Okay. So this is 1, 2 as a pair. Okay. So we have this is 1 or 2 here. So this cannot be 1 here. This is 5, 7 as a pair for E and A. So that eliminates 5, 7 in the rest of the row. No 1, 2. This is 3 or 9. We have a 3, 9, 3, 9 pair in row 7, which eliminates 3, 3, and 9 in the rest of the row. So this is 4, 6, 8, and is the even 4, 6, 8. So this must be F. So this is guaranteed to be F here. We need an F here. F and W, I guess, is a pair now. And we'll make this W. So this is odd, and it's 3 or 9. F has to be consecutive with it. 6 is not consecutive with either of them. So this cannot be 6, so this must be 6 here. This is 4, 8 as a pair. C and F are here. So this must not be B, this is F. So B has to be 6. So this cannot be B here. B has to be one of these two. B is one of these three. But let's just do... Okay, so this cannot be B. We know... So that's a 6. All the B's then are 6s. Which has to be next to 5 or 7. And it's either E or A, but it cannot be A, so this must be E. So this is 5 or 7. This can't be 5 or 7. It's D, which is 3 or 9. This is 6, so this must be 4, 8 here. This is F and W as a pair. This can't be 6 here. We don't know what these are. F and W. This is F and W. This is F. A and E. So G has to be 9. So G is 9. Which eliminates 9 from the rest of the row. And this is 6. So 6 is consecutive with 5 or 7. It cannot be A. So this must be 6 and E here. This is 5, 6, 7 as a triplet, which eliminates 5, 6, 7 in the rest of the row, so no 5, 7, no 5, 7. This is 1, 2, or 3. This is 6 here. This is W as 3 or 9. This 3 eliminates 3 in the rest of the box. Well, we have a 1, 2 pair now in row 6, which eliminates 1 and 2 in the rest of the row. This can't be 1 or 2. It's 3, which eliminates 3 in the rest of the box. And this can't be 1. This is 5, 7, 9. So we know this is A and G here. So no, this is specifically an AG pair. That's 5, 7, 9, which eliminates 5, 7, 9 in the rest of the row. So no 5, 7, or 9. So A's here, E's here. G has to be one of these two. So this is 9, A and E, 4 and 8. We have to have a 2 somewhere in box 2. And 2 cannot be here because we are guaranteed a 2 here. So this must be 2 here. And since this is 2, that eliminates 2 in the rest of the box. So this is 1, which makes this 2, which makes that 1. Therefore, 2 cannot be in the rest of this cage. Or, sorry, cage, I meant. So therefore, this must be a 2 here. And this must be A or G here. So A or G is there. We're not sure which. So this becomes an AG pair. This is E, so it's not 9. Okay. So we have F and W, F and W, F and W, E and C. This is C. This is C, E, and C. So this must be the other 1, 2 here. This is the green pair. And the other 1, 2 is one of these. Okay. 3 cannot be here. Where is 3 in this cage? Can't be any of these because of 3's in the row, so it has to be here. So this is 3, which means this is consecutive. That makes this 9, so that's 9. This has to be then 3 and 4 to be consecutive. So this is 4. C is 8. So F is 4 here. A is then consecutive with 4 and 6, so A has to be 5. We can remove these and these and these. So A has to be 5. E has to be 7. We can remove that and that. So then E is 7. That means this is a 3, 4 pair. This can't be 7 anymore. It's 5 or 9. This 9 eliminates 9 here, so this is 5, which makes this 9. This 5 has to appear somewhere in the box 1. Cannot be in this cage, so this must be 5. And remaining digits in column 1 are 3, 4, 7, and 8. This can't be 4. This is 8. That's a C. This 5 eliminates 5 in the rest of the region. This is a 6, 7 pair, which eliminates 6 and 7 in the rest of the cage. So this can't be 7. This is a 1, 2 pair, which eliminates 1 and 2 in the rest of the box and cage. So no 1, 2, 5, 7. It has to be 9. This cannot be 4. This is 8. So this can't be 3 or 8. It's 1. This can't be 1 or 2. It's 4. This can't be 2 or 4. It's 8. So this must be 2, 4, and 8 here. So that's 2, 4, and 8, which makes this even. That leaves this as a 3. We have 1 here. This cannot be 1, 3, or 5. It's 7 or 9 that's consecutive with it. This is 6 consecutive with 7. That eliminates 7 in the rest of the box. So this is not 7, that's 9. This cannot be... This has to be 2 consecutive with 3 to form a cage. Therefore, this can't be... This has to be 1 left here. So we have 1 here. This is 1, 2 as a pair. That forces this to be 7. This 2, 3 pair eliminates 2 here, so that's 1, which makes that not 1. That's 2, which eliminates 2 here, so that's 1 and 2. 4 eliminates 4 here, so it's 8 and 4. That leaves this digit as 8. This is 6 and 7 consecutive. That's 1 and 2. 2, 3 pair eliminates 3 in the rest of the column, so it's 4. This is 3. These are consecutive, but cannot be 3, 4, so this is a 7, 8 pair, which eliminates 7, 8 in the rest of the box, so this can't be 7 or 8. That's 3 or 4. Remaining digits in this cage are 3, 4, 6, or 9. So this cannot be 4 or 9. This 4 eliminates 4 here, so this is 3, which makes this 4, which makes that 3. That 3 eliminates 3 there, so it's 6. This cannot be 6 or 9. Sorry, cannot be 6 or 3. So this is 4, 9 as a pair. 2 eliminates 2 here, so this is 3 and 2. Remaining digit in this cage is 3. So that's 3 there. This must be 8 because these Z's are these digits here. Okay, remaining digits in row 9 are 1, 2, 5, and 9. This can't be 5 because of 2, and it can't be 2. This can't be 1 or 9 because of 1 or 9 in the column. These are consecutive without 3, 8, or 9, so 2 cannot be part of this. Well, where is the 2 in the column 9? There's no 3 and 8. 4 would require a 3 outside, and 7 would require 8 outside, so this has to be 5 or 6. It cannot be 6 here because that would force this to be 7, so this has to be 5. So this is 5 with 4 and 6 here. 5 eliminates 5 here, so this is 2, which makes this 1, which makes that 9, and makes that 5. 2 eliminates 2 here, so it's 1 and 2. 2, this leaves this as a 1. Where's the 2 remaining in row 3? This is 8 here, which eliminates 8 here, so it's 4 and 8. 4 eliminates 4 here, so it's 6 and 4. 6 eliminates 6 here, so it's 7 and 6. Again, where is the 2 in row 3? It has to be here, which is consecutive with 6 eliminates 6 here, so it's 7 and 6. 4 eliminates 4 here, so it's 9 and 4. 8 eliminates 8 here, so it's 7 and 8, which leaves this as 7 and this as a 9. Whew! That was, yep, that was definitely hard. Pretty interesting interactions, though, between them. And where things had to be. It's sort of, yeah, there's essentially, like, the gray cells also acted sort of independently as its own region, right? That connected, sorry, that had basically the digits 1 through 9 in that set, right? So we have the gray 1, the gray 2. Where's the gray 3? The gray 3 is here. Gray 4, gray 5, gray 6, gray 7, gray 8, and the gray 9 is here. Right. But yeah, that was fairly hairy, but interesting, very interesting setting. You were definitely limited on a lot of things of where these things could be, right? So that was interesting. But getting around to finding those is kind of... the execution was definitely... I think it was very hard. The logic isn't that hard, but the problem is that I don't think we're well enough trained at these things to be able to figure these out with alacrity, right? So, anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.